That's good. Okay, so 3 servers. Server number 1, server number 2, and server number 3. ESXi host, ESXi 1 or 01, and VC and DS. Windows Server, first one is Windows Server, yes. Huh? Did I change the color of the marker? Oh, can I? Okay, sure. Yes, I'll change the color. Yes, here. So, this is fine for light.
It's light, that's better.
Okay. So, VC, VS, ESXi1 and ESXi2. So far what we understand is this. So we know that this is all from vSphere. vSphere 5.5 and 6. So we're studying both 5 and 6. Now under 5, one word for this. If somebody asks you what is vSphere, it is a suite of products. It's a suite of products. This is the first sentence we learned about vSphere. So vSphere is not just one product, it's a suite of products. And among these products, there is one product that is known as ESXi host. And ESXi host, as we know of, it's a hypervisor. We know that. It is a hypervisor, and it is a OS as well. It's a hypervisor. It is a OS as well. Now, what is the definition of hypervisor, Azhar? What is a hypervisor?
It's a Microsoft. No, so hypervisor is a
Virtualization. Thank you, part 2, Azhar. It is virtualization. It is, right? Okay. But hold on, this is not the right answer. It is virtualization. I do understand, but this is not the right answer.
Microsoft hypervisor.
Yes, that is Hyper-V. That is Hyper-V. What is hypervisor?
So that is a virtualization.
That
you are using the hardware
and
combination of hardware and the operating system.
no.
Servers hardware components installed.
You're almost there. A software that enables you to create VMs. A hypervisor is a component. This is a right definition. Good remembering. It's a hypervisor is a component that enables a computer to create more VMs inside. Without a hypervisor, you cannot create VMs inside. So hypervisor, you need to remember that it is a component with which we can create VMs inside. Without a hypervisor, you cannot create a VMs inside. Okay, so hypervisor is that component. Now, a server that in which you need to create VMs, it must be a hypervisor. There must be a hypervisor. A server without a hypervisor, you cannot create VMs inside. So most of the time, the operating system comes with a single user. So this is a single user operating system. All the Windows 7 we are using are single user. And how do you install VMs inside? We install VMware Workstation. So VMware Workstation is a hypervisor. And hypervisor is a hypervisor. So this is, if I say hypervisor, hypervisor. Which of the softwares are hypervisor? So Hyper-V is hypervisor. Hyper-V is a software from Microsoft. ESXi is a hypervisor too. ESXi is a hypervisor and it's a product of VMware. It's a product of VMware. And Zen Server is a hypervisor too. Zen Server. So third one is Zen Server. Zen Server is a product of Citrix. So these three major hypervisors, there are enterprise level hypervisors. So with all these three, we can create VMs inside. Okay. Now, Now, so where is VMware Workstation? VMware Workstation is also a hypervisor, but it is just for test environments. It is just for training or test environments. VMware Workstation. And so here I'm going to say VMware Workstation. VMware Workstation is a product of VMware. So VMware's enterprise hypervisor is ESXi host. VMware's test hypervisor, test or training purposes, VMware Workstation. So that is VMware Workstation. So VMware. So hypervisor, guys, it's a software that enables us to create VMs inside. That's the main definition. So please remember it. This is one-liner for interviews. Other than this, it will be very difficult for you to give them a definition. Okay, it is a layer that works in this operating system and this and that and all that. No, just a very simple definition. It's a component that enables us to create VMs inside. Now, without ESXi host, can we create VMs inside? No. This is why we installed ESXi on this. Can I create VMs on this being a vCenter? No, you cannot, because vCenter is not a hypervisor, but vCenter is a software that can manage hypervisors. So vCenter has its own features. Okay. So we started with VCF 5.5 and 6.0. First component is ESXi host. ESXi host is a component that is a hypervisor, that is the operating system. And then second component is vSphere client. And vSphere client comes in two different versions. It comes as a legacy client, and it comes as a web client. It comes as a legacy client and it comes as a web client. And the third one here is VC. VC is also a component of vSphere 5.5 and 6.0. And VC also comes in two versions, appliance and Windows-based. And then other than these components, there are other components. For example, there is vMotion is a component of vSphere. DRS is a component of vSphere, then SDRS is a component of vSphere, and then HA is a component of vSphere, FT is a component of vSphere, and all these. So far, how many of these components do we know of? So far, we know what is hypervisor, what is OS, what is ESXi host, what is vSphere client, what is legacy client, what is web client, what is vCenter, appliance, web. And now we have reached to networking. We haven't started vMotion, DRS, and all these advanced. Before that, we started with networking. So here, I'm going to say that there is one more component which is right here, and that is networking. And networking, we went through in huge detail what is networking in this. Now, networking comes with networking. You need to remember there are vSwitches. And there are two types of switches. What are those switches? One is standard switch. Second one is VDS, vSphere distributed switch. This is a switch that can manage multiple switches at the same time. So one switch that can manage multiple switches at the same time. This is one standard switch. And then in these switches, there are port groups, and ports. There are two types of port group. There is VM network port group and management network port group. Guys, I'm just writing small little acronyms because we went into detail. I'm just reviewing this information. Now I'm making this because so that it is easier for you to make mind maps. Guys, you need to make mind maps. Start making mind maps. Some of you did send me a picture of a mind map that you created. Guys, trust who?
Yes, sir.
Yourself and me at the moment. Guys, trust me. As soon as you create a mind map, a real picture is created inside. It's not about that you are wasting time in creating mind maps. No, a real picture is being drawn inside your brain. So when you create this mind map, a real picture will be drawn. So Don't take it lightly, guys. This is a very strong way of remembering things. So here you have port groups and all that, and management has 4 different functions. We all know that, and then and so on. And now where we are, we have reached to storage. So storage. So now we have reached to storage, and I'm gonna start from storage now. Question? Yes. Huh? VDS is a vSphere distributed switch. vSphere distributed. Were you there in the last lecture? Oh, you missed it. We spent 2 hours on this, and it was very, very important. So VDS for you for now. Just a little a quick explanation. VDS is used to manage multiple switches at the same time. Multiple switches at the same time. Let's say I have, these are all ESXi hosts. So ESXi host 1 has 40 machines. ESXi host 2nd has 35 machines. This one has 50 machines, and each one has 40 machines. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 ESXi hosts. And 14 into 40, how much? Ta-da, nobody knows the math. 1600. No way. 14 into.
Said 40 into.
Yes, 14 into 40.
Okay.
I said 14 into 40.
Okay.
560.
You said 560. Sure. So 560 VMs we are managing here. 560 VMs. Now in each host there is one standard switch. If I have to do one change on each one of them, there might be a possibility of error. So what we do, I will create one VDS. So this is my VDS. I'll set this VDS with the port groups and everything, and then I'll connect all these hosts with this. All the network setting will go onto each one of them, similar setting. So this is a VDS. VDS is a vSphere distributed switch with which I can manage all switches from one place.
And this is connected to standard switch?
This is connected to standard switch on each machine, yes.
Not to manage. Not to manage. Not the
it is connected to switches, yes. And VM kernel is inside the switch. Okay.
So,
now if you need more information on this, you can sit with me for 15-20 minutes, because we have spent a lot of time, and I'll explain you 15. It's not that difficult. Okay, here, let me log in. Shams, you're saying something?
So the multiple switch, like the standard multiple switch.
Yes.
So the standard switch.
Multiple standard switches, yes. What is the importance of storage in virtualization, Sami? It is very, very important. Right answer. Excellent answer. Explain a bit more, please.
Because all the data is stored on the storage.
All the data is stored in switches. All VMs are stored in storage. All VMs are stored in storage. And the most important thing about this ESXi host is not ESXi host itself. Actually, it's all about the VMs here. Where are these VMs? If these VMs are stored in local data, then it is like you're all eggs in one basket. If this ESXi goes down, the VMs will go down with it. So guys, in all of the environments, what we do, we create a shared storage and then place all the VMs outside the local storage. This is exactly the same concept of when we save our valuables in a locker in a bank outside the house. So you don't want to save all your valuables inside the house, because if anything goes wrong in the house, then it might affect your valuables as well. So instead, we take our valuables, our gold, money, this and that and everything. We take it where? To a bank in a locker. So this is exactly the same thing. The most important thing is these VM guys for the company. For the company, the most important things are these VMs, because these VMs are making revenue. These VMs are making revenue. On these VMs, there are thousands of users connected. So you cannot risk them. So instead of saving them in a local storage, we save them in outside storage. And today, we need to learn what type of outside storages are there. Okay. Now, a quick recap of last week. We started with, we said that all storage starts from a basic simple disk. I mean, you're right. Yes, it's a raw disk. It is a raw disk, but all the storage are starting from a simple disk. Now, simple disk is to start with. We all know that simple disks. So here I'm going to say storage. And all storage start from a disk, any disk. And disk is to start with. You cannot write anything on a disk until you format it. Now, these disks, so first of all, it is a raw disk to start with, and then you format them. And the format is different in different operating systems. Remember? So what are the different operating systems? So when we format them, we format them from Windows. We can format it from Linux or Unix. We can format it from ESXi host. Okay, so when you format it from Windows, what type of file system will be on it?
NTFS.
It is NTFS and REFS as well. REFS. Excellent. And when it is formatted with Unix, it becomes NFS. And when it's formatted from here, it becomes VMFS. So this is how. Now, for us, the most important part to understand in VMware training is this. What is one-liner for VMFS? It is designed for large file system. It is designed for large files. It is designed to handle large files. So large files as big as 64 TBs. You can have one file of 64 TB. This is now the current limit. Before it used to be less. So in VMFS, in which FS?
VMFS.
Everyone, I can't hear you. VMFS. Guys, in VMFS, so here, look at this. How many versions are there for VMware? So here, if I'm going to say VMware vSphere, so it came as 4.x. No, actually before that, 3.x, 4.x, and then it started with 5, and 5 upgraded to 5.1. 5.1 upgraded to 5.5, and now it is 6.0. Guys, till 5.5, till here, in VMFS disk, you cannot have a file more than 2 TB. The maximum file size till this version was 2 TB. So now, as soon as the file reaches a 2 TB, it cannot grow any further. So in previous all versions, the file can be of, now in version 6.0, that file size is increased to 64 TB. Guys, 64 TB, I'm not talking about a disk, I'm talking about one file. And in VMware, it's really easy to have files this big. Why? Because all the VMs have the disk is larger. It is exactly this. So if I go here and go to my documents here, and within VMware, let's say if I go to any one of my servers here, let's go to my vCenter. So in vCenter, let's see which is the biggest file here. So in vCenter, the biggest file here is, you see, this is the biggest. First of all, this is one file actually. This is two. So this server, the same server that I'm running as a vCenter, RAM is using 9 GB, and this is just one file. Do you understand what I mean? Guys, in vSphere, it is very normal that vSphere plays with large files. Now, as you can see here, the disk of the same vSphere that the vCenter I'm using, it is using 4 GB. So this is one file. For us, it's one file. For VMware, it's a complete disk of that VM. So this is why I said that VMFS is designed to manage large files. Now, what is management? What management is that this file will be open and it will be continuously read and write from this file. And just for one VM, you see how many files are being used. So this is a big file, which is 9 GB. Second file, this is 4 GB. Third file, this is 4 GB. Fifth file, 4 GB. And the sixth file is 3 GB, then 3.5 GB, then 2.9. See how, just for one VM, how many big files it is working with? And this is just a test environment that we are working. In real environment, they easily go 100 GB one file. 100 GB one file. Easily, because real environment servers are being used and we don't shut them down. They are being properly used. So guys, this is why VMFS. So now, for interview question, we need to remember. We need to remember that till version 5.5, the maximum file size in VMFS was 2 TB. It cannot get more than 2 TB in previous version. But in most current version 6.0, now that same file size can be 64 TB. So now there is no limit. It is almost no limit at the moment. Okay. So storage, disk, raw disk format, you format in this manner and this becomes this. Now, when it comes to so storage started from a disk 1. Is this understandable? Storage started from what? Simple disk. It was a simple disk. Is it a simple disk or not? It is a simple disk. It is a simple disk. It's a simple disk? No? Okay. No? Who said no? How can you go against me? How come? No, who said no? It's fine. No, it can be a simple disk. But why did you say no? Yes, excellent. Yes. So it becomes a real disk when it is formatted. Here it was a simple disk, but you're right. Yes, once it is formatted, it's not a simple disk. Now, one more time, just one quick more time, guys. I'm spending long time on this because I want these concepts to be embedded, not stored. Remember, do we know the difference between embedded and stored? Huh? Embedded data. Have you ever gone to a jungle? Not a jungle, maybe. Huh? Yes, exactly. So if you go on to some Sehat of the Mukam, there are trees, and on trees there are sometimes named engraved here. So N plus F, something like these. Engraved. This is known as embedded. Why do they engrave them? Because they want to see them nasal dar nasal. So people, their children, their people will say, oh, our grandmother and father, their grandparents came here and they embedded. God, this is known as embedded. What is stored? On the same tree, you make maybe you make a hole and you put something here. This is stored because it can go away automatically. So guys, I want these concepts to be embedded inside. And the only way to embed is to use our all 4 senses. You're listening. No. You're seeing, you're listening, and we must be discussing, and we must be writing, and plus, just to help this all out, make mind maps, guys. Just to help this out. You don't need to write huge big stories. You need to remember this. So we need to be embedded, not stored. Okay? Okay, here. Let's look at this. Embedded, we need, so storage starts from a disk. And disk is raw to start with, and we format them. If it is formatted in Windows, it becomes NTFS. If it is formatted in Linux Unix, it becomes NFS. If it is formatted in ESXi host, it becomes VMFS. Guys, at the end, these all will become a storage. Now it became a real storage. So you see, It started with a raw storage and now it became a usable storage. Now it became a usable storage. Now, when it comes to a usable storage, guys, usable storage are of two types. There is something called a local storage, and external or shared storage. Now, local storage is always inside a computer. So local storage is always inside a computer. So here I'm going to say this is inside a computer. Inside a computer, and computer can be a desktop or a server. So whenever we talk about a local storage, basically we are talking about a local storage inside this server. This is a local storage. Guys, in VMware, we need to really learn about external or shared storage. You need to be an expert specialist of shared storage. So shared storage it is. So we are right here. And when it comes to storage, so right after this, so you started with a understanding of storage. Understanding of storage started with a raw disk. It was a raw to start with. It was raw to start with, number one. Number two, it was formatted. And when it is formatted with Windows, it becomes NTFS. When it is formatted with Linux, when it is formatted, so it is this. And then it becomes the usable. So I'm going to say this is a usable storage. This is a usable storage. Number 7, and usable storage is of two types, which is a local storage and external storage. And now I'm going to start with external storage, because local storage we already know. Local storage in ESXi. Local storage in ESXi, what do we call it? Data store. Remember? Data store in local disk in ESXi, we call it a data store. Once you add a second disk, data store 1, data store 2, data store 3, and so on. It becomes more and more. Okay, so it's right here. Now, right here, storage, we are talking about shared storage, external or shared storage. Now, these storages, external or shared storage, which is right here, it is of two types. It is a file level storage and a block level storage. So this is a file level storage. File level storage and a block level storage. File level storage and block level storage. Which one is faster? Block level storage is faster. Now, a very quick explanation. So this is a screen from last time. Actually, we were right here. Storage, file level storage. This is file level. This is block level. And in this, it's slower. It is faster. It is less reliable. It is more reliable. It is inexpensive. This is expensive. Remember those things that we discussed last time? So here I'm gonna do the same thing. So here, file level storage, number 1, it is slower. And this one is faster. Now, how come it is faster? Why is it faster? Data is being transferred as small blocks of information instead of a complete file. So basically, in here, if this is a complete file, this complete file is being moved from this computer to this computer. If it breaks in the middle, it will start from the file again. In block level, it doesn't happen like this. In block level, it is being transferred as small blocks. So small blocks are going, if it breaks in the middle, first of all, it is block, it is faster. It doesn't have to copy the complete file into memory. Now, how does copy work? Guys, copying works in this manner. Let's say this is a file that sits on this computer. Let's say it is a 50 GB file and it needs to be copied here. Guys, what happens is, so you are copying from C drive, Umar. You're copying from C drive of this computer and needs to go here, right? What happens is that this file first will be copied into the memory and then it goes to the disk. So it waits for the data to be copied in memory and then it is copying in the disk. So it is in that temporary waiting area, then it is copying. In block level, it is the same thing, but now it doesn't have to copy the complete huge big file. It is copying small data. So small data. So this is why, guys, block level is faster. Read, write, and everything is faster in block level. Okay. Now block level, in order to have a block level, you need to have a special type of storage. So in a file level storage, we said that it has two types. It is a DAS and it is a NAS. It is NAS. DAS stands for direct access storage. And what is the example of DAS?
So direct attached.
Sorry, it is direct attached storage. I was thinking it doesn't seem right. Yes, direct attached storage. And whereas NAS is network attached storage. Well, how do we remember it, Ali?
Which ones of the NAS? The NAS is like a external box which we connect with the network through IP address.
Yes, excellent. Good remembering. That NAS is always like connected on a network and DAS is connected directly to a computer. So in this case, you do have servers on the network. So this is a network, but we connect a special disk here. So it has 3 disks, let's say 2 disks of 2 terabytes, 2 terabyte disk in this 2 terabyte disk. And this is connected through IP address on the network. Let's say this is 98. So this storage, this is a NAS. This is NAS. And then these both machines can access it over the network. This is why it is known as network attached storage. Whereas direct attached storage, same thing. If you have 2 computers sitting on the network, direct attached storage is it must be connected here on a computer like a USB. Like USB. So USB is not connected to the network, but you must connect it to a machine. Machine here, it is direct attached storage, yes. It's not considered as DAS or NAS, but it is considered as SAN. It is a block level storage. It is part of this. It is. But you're right, it seems like it is something like this. It is something like this. Yes, it is something like this, but it is a block level storage. Okay. So direct attached storage, NAS, and this is network attached storage. Now block level is also of 2 types. So here I'm gonna make it. So 2 types. Number 1 is iSCSI, yes. Number 1 is iSCSI.
And fiber channel SAN.
iSCSI. And number 2 is SAN. Actually, no. It is of SAN.
Yes.
So block level storage is SAN. And SAN is of 2 types. iSCSI and SAN. And FC. FC is fiber channel. And this one is independent internet
small computer system interface.
Internet small computer
system interface.
Computer system interface. Guys, in both of them, block level storage, both of them are work like NAS. Both of them work like NAS. So both of them, I'm going to make diagram of both of them. So both of them are this. So let's say you have a running network of 2 ESXi hosts. So I'm going to say this is all ESXi hosts, by the way. ESXi1, ESXi2. This is also ESXi1, ESXi2. This is ESXi1, ESXi2. So here I do have ESXi1, ESXi2. Let's see the example first. Now in both cases, guys, they are connected to network. Are we on the same page? Are we all on the same page? Yes or no?
Yes.
Yes, we are all on the same page. So here, yes, E1, E2, E1, E2, and all that. Okay. So right here, E1, E2, E1, and E2. Now, in both cases, guys, you need external. This is an example of all external storage, remember? So if this USB is external storage, NAS is also external storage, and in this case, you do need either iSCSI or FC. In both cases, it will be connected to the network. So this is connected to the network. In both cases, it will be a device. It will be a device. There will be a iSCSI device. In this case, it is a iSCSI device. And in this case, it is a SAN device. It is FC device. So FC, in this case, it is FC. In this case, it is SAN. Now, in both cases, you do need external storage. Guys, just like we use USB. Why do we use USB? Because you need to save something externally. So in USB, is there a storage inside USB?
Yes.
Yes, there is a storage. So basically the storage sits here. It has a small storage depending on how big your USB is. It might be 2 GB. It might be bigger, 34 GB or whatsoever. And even in this case, even in NAS case, it is all about the disks inside, how big the disks are inside, right? So this NAS can be of 2 TB. So this complete NAS is of 4 TB capacity. So the amount of storage they have in so this all depends on what guys, even in this case, it's all about storage. So what we do, you buy a iSCSI device and you buy this, but the most important thing is that how much storage you can store in this. How much storage do they have? So in storage, we are going to, when you buy a iSCSI device, we're going to tell them, okay, how much storage do I need? I need in this 10 terabytes. So they would say, okay, 10 terabytes. You need 10 terabytes. So okay, we're gonna give you two disks of, let's say 4 terabytes. So this is one disk of 4 terabytes, second disk of 2 terabytes, and 2 and 2. So this is how they are giving you. Now they can give you one disk of 10 terabytes as well. But guys, just because you need to have that redundancy, maybe you might need to apply RAID levels inside to protect the data. You must have, and these all come with multiple disks inside. Exactly like this server here. This server here, or if you look at any server, they have multiple disks. And I'm going to show you what that is. Okay, so it has 4 disks inside. And SAN also comes with the same thing. So when you go and buy SAN, and which SAN do we know of for now? EMC, remember? Remember EMC? So our SAN that we know of is EMC. It is called VNX. And it was, remember, it was 5200. And it comes as 5400. It comes as 5600 and so on. Okay. Quick 1-minute exercise. If your internet is working, just search for this. EMC SAN. You need to look for EMC SAN. So here, I'm going to go here in Google. I'm going to Google this and see, I'm going to say EMC VNX 5400, 5600. I need to see all these. So as soon as you do, change it to images. Just first of all, see visually how does it look like. So change it to visually. Now within visually, it looks like this. So here it is, this is VNX. And if you look at it, so if you look at it, this one, so right here, it comes as VNX E3150. 3000, 5400, 5600, and so on. It comes in many different numbers. But guys, the one thing visually you can see that the bigger the number, the bigger the size. What is the size? Because they can store more storage. It is just about storage. So when you have more storage, it is more expensive. It is all about storage. How much storage you can store in them. Now, if you look at the comparison. If you just look at the comparison of these, let's look at this comparison here. And let's see. So you see the biggest difference now, the speed, there is a speed difference, there are some features difference, but the biggest difference here is it is 5200, 5400, 5600, 5800, and it's a difference of disks inside. So first of all, here you can have maximum drives of 125, and this one can have maximum of 250, then 500, then 750, then 1000, then 1500. So this is all about how many disks you can have in this device. So the more disks you have, the more expensive it is. So guys, this brings us back to our same concept, the previous where we started from. All the storage starts from a disk, and it ends with a disk too. It is just the middle technology. What technology are you using in the middle? So in order to use this raw disk and use it as a usable disk, what technology are you using in between? So in order to get a shared storage, you can use a DAS technology, which is the cheapest one, but it doesn't give you a speed. It doesn't give you a flexibility. If this disk is connected to one disk, if you need this disk, you need to take it out and connect here. Although you can share it, but it doesn't give you the same speed, same features. Then the second thing, again, from raw disk to usable disk. Do you want to use NAS? Yes, you can use NAS. It is on the storage. Both can use it, but then it is slower. It might be cheaper, but it is slower. And then comes your fast SANs, your fast storage. These fast storage comes in two types, iSCSI and FC. So the first one is iSCSI, and second one FC. FC stands for fiber channel. Guys, in all of them, visually look at it, that they are just devices with disks. They are just devices with disks. But now we need to see, so this is a iSCSI device with a disk. This is a SAN, a fiber channel device with a disk. So let's say we are trying to buy, our requirement is, let's say our requirement is to have 500 disks. Let's say our requirement is to have 400 disks. So which SAN would I go for? 5600, because I cannot have 400 disks in 54. And guys, trust me, there is a huge big price difference between the two. This might be $10,000 and this might be $50,000. Yes, so it's a matter of these, and then it's a matter of some, and most of the time they all come with two storage processors. They come with I/O ports and memory, and you can see some memory differences here as well. So this one gives you can work on 32 GB memory, whereas this one can go maximum of 24 GB. So there is a give and take, yes.
In all of these storage types, the medium is same, like the disk is same, but the method of attachment,
Connectivity method is different, yes.
What is that method actually? We know it, like, okay, this is iSCSI, but iSCSI has, let's say, a disk which is fixed disk, or which just will directly in. The direct access, same thing, same disk can be directly attached, can be in NAS, can be
Exactly. Yes. Then what is the big difference? And I'm going to go through this now. Okay. So since we do understand, guys, whenever you talk about these storages can come in 4 different types: a DAS, a NAS, a iSCSI, and fiber channel. So fiber channel is right here, guys. Among all of them, I can tell you the most expensive one is this. The most expensive. So I'm going to say this is the most expensive one. And here, actually, I should add 4. And this one is the second inexpensive. So it is less than, you can get this, but this is getting expensive as well. And then this one is less expensive, and this one is the cheapest. So the most expensive one is this, fiber channel SAN. Now, why is it more expensive? Guys, the one thing that you can remember, and there are many differences, but one thing always remember, guys, fiber channel is the most fastest and reliable storage available so far. There is no other storage that is faster than fiber channel and reliable and efficient than fiber channel. And there is a reason for this. There is a reason for this. So you can think of this as a Ferrari or a Corvette or
Audi.
even better than Audi. This is Audi. This is a sorry. Which one? Bugatti.
Bukti.
Okay. I don't know. I'm just giving you an example. Okay. Yes, it might be Lamborghini or all these other cars. Okay. Just to give you that difference, guys. Just remember it visually. Once you relate it to something, so always remember, fiber channel is the most expensive one. It is not only the most expensive one. It is the fastest, efficient, reliable, and it is a block level storage. It is a block level storage. So this is the fastest, efficient, reliable, and all that. Now here, guys, here. Now let's see the difference. Now let's say you bought which one? 5600. So you bought 5600 for your company. And how much maximum disks you can have in this? I can have maximum of 500 disks in this. How much maximum RAM it has? It can go up to memory 24 GB. It can go up to 24 GB. So let's say 24 GB. And it's saying per SP. So it is 48 GB actually. So it is saying memory per SP is 24 GB. And there are two SPs. So SP is a storage processor. So since it has two storage processor, and each storage processor it can have 24. So basically this unit can work with 48 GB of RAM. So I'm gonna say SP. This is this. And guys, please remember it in this manner. Whenever somebody talks about EMC, they will further ask you few more questions. That as soon as, and they will definitely ask you, have you worked on any storage? Your answer is yes, we had EMC VNX 5600. Okay, can you tell me a bit about that? Yes, this is 5600. It came in different versions as well. It comes as 5400, 5200, but this is 5600. It can have maximum of 500 disks. It can use 24 GB of memory per SP. Can we remember this information? So it's not only you need to remember just the name, just remember some of the specs as well. This is why I opened it. This is why I'm discussing it. So one more time, what type of storage is it?
FC.
It is FC. What company is it?
EMC.
It is EMC. What model of storage?
VNX.
Umar, what model of storage? VNX. What is the number of storage? 5600. How much disk maximum can be in it? 500 disks. And how much memory per SP? 2400. And guys, I can say that this is not less than 30 grams. It is even, I think it is more than this. Now it's all about storage. It's all about storage. Let's look at it. So let's say for now you have 10 disks to start with. Your company said, okay, it can have 500 disks, but we're gonna start with just 10 disks. Okay, we can start now. If they are starting with 10 disks, why do you think that they bought this expensive storage? Because they are thinking, they are planning for next 5 years. They won't be buying this again and again. So they are planning for next 5 years. So then as soon as, and it will fill up really easy. So here it has, let's say 10 disks, and each disk is of 1 terabyte. So 1 TB, I'm gonna say each is of 1 TB. So for now they have 10 TB in this. So guys, now let's see. This is a disk. This is a disk, this is a disk, this is a disk. These are all disks. And whenever you have a storage like this, guys, in all of them, you have a new USB. Is it usable? No, you have to format it. Same thing, you have a new SAN, format it. Same thing here, you have new disk, format them. For now, they are all raw disks. They are all raw disks. Now comes back to your question that what makes it more expensive or less expensive. Guys, what makes it more expensive? SAN uses its own infrastructure to provide you the storage. So SAN, this uses its own infrastructure. So SAN, I'm going to say SAN uses its own infrastructure to manage storage. It uses its own infrastructure to manage storage. Whereas iSCSI uses TCP/IP to manage the storage. So iSCSI, it uses, I'm going to say iSCSI uses TCP/IP to manage storage. Manage or connect to storage. Now, what does that mean? Guys, that means is that it has its own infrastructure when connecting to the storage. So first of all, hardware-wise, everything its own. So meaning when you get a FC, so first of all, let's get iSCSI. In iSCSI, all you need to do, buy a iSCSI device. Let's see what iSCSI devices are available. Yes.
So both are SAN, but you have written under FC that you're talking about SAN or FC? You're talking about FC.
Okay, just a second. I'm gonna explain that as well. Yes. So here, iSCSI. Let's look at it. This is NAS. Here. So iSCSI SAN. iSCSI SAN is sitting right here. iSCSI SAN, this is iSCSI SAN. It's a device. It has disks inside. And all you need to do is connect this device. You buy a new device, just connect it to your normal network. You don't need anything extra. So meaning you get a SAN, you get iSCSI, and it is connected right to your TCP/IP. So this is why I said iSCSI uses TCP/IP to manage, meaning it is connected to your normal network. So this iSCSI will be having the same IP address on your network.
So it also has a network card.
It also has network card. It also has cables, and it connects here. So you can assign any IP address, and then on top of which it is connected. So in many aspects, it's like SAN. It is like NAS. But NAS, we all know that NAS is a slower storage because it's a file level storage. The technology that is being used in order to read-write data, that is NAS. Here, the technology that is used to read-write data, that is iSCSI. So in iSCSI, you don't need any extra infrastructure. In iSCSI, all you need to do, get an iSCSI device, connect it to the network, and then it starts working. Whereas, now let's look at fiber channel. Guys, fiber channel comes with its complete network, its own network. So now I'm gonna show you how it is. So first of all, when you bring a iSCSI, fiber optic device, which is a fiber channel device, guys, it has its own. So on server side, you need to attach special cards for this. So this won't be connected to your normal Ethernet card. This device needs, so this is a SAN device. I'm going to say this is a SAN device to start with. So first of all, you do need a SAN device. Secondly, on the computer side or the server side, you do need a special device that is known as HBA. And HBA stands for Host Bus Adapter. HBA stands for Host Bus Adapter. Host Bus Adapter. Now, So this device cannot connect to your normal network. It cannot. Whereas iSCSI can. iSCSI can connect to a normal network, and then people can access it just through your normal network cards. So there are normal here on this side, they are just using normal network card and they are connected to iSCSI. So in iSCSI, you don't need special infrastructure. So this is why I said SAN uses, and especially I'm going to say FC SAN uses its own infrastructure to manage the storage. So what is its own infrastructure? Its own infrastructure meaning you need to have a SAN device, FC SAN device, and then on the client side, it cannot work with normal network card. You must have a special network card that is known as HBA. And HBA stands for host bus adapter. And this is a special card that needs to be connected to SAN. If you don't have this card, then you cannot connect to fiber channel SAN. Okay? Huh? Which one? No, these are PCI cards. These are PCI special cards that connect inside. They have a special cable as well. Now here, if we look at this here, I'm gonna say fiber channel SAN, fiber channel SAN, and change it to this. Here we can see. So first of all, these are special cables. There are fiber cables here. So it's right here. So this one. So whenever you have a SAN, so this is a SAN device right here. This is a SAN device, and it has, these are the disks here. There is a small display just to show you which disk and just to show you some alerts if there are any. And these are the disks. And you do need HBA. This is a special HBA. So HBA connects to a fiber switch connects to a SAN. So in order for these to work, in between this, you must have a fiber channel switch.
We saw in this machine.
It is here on this machine as well. It is there on this machine as well. We're going to put it there in break, and you can see the fiber channel cards on this machine. So right here, you do need a fiber channel. So I'm going to say this is a fiber switch. This is a fiber switch.
And this is, I think, even required because of the medium, it's fiber to
Fiber to the SAN, yes. So your key, and so first device is this, second, third device is this. So you do need a SAN device. You do need a card which is known as HBA, which is right there, up there. And then you do need a fiber switch. And fiber switch has ports inside. These are special for storage. And then in between, in order to connect from here to here, you need a special fiber optic cable. So fiber optic cable is this cable right here. This is a special fiber optic cable. Now this cable, so this is a special fiber optic cable. As you can see, it is different. So right here, you need a special fiber optic cable. I'm going to make a cable here. And most of the time, this cable is orange color just to separate it from other cables. So in all of the networks, in all of the, you will see it either in gray color or in orange color. It's an orange color, so that, and it's a very sensitive cable. If you unplug it in slightly different manner, it breaks. And this one cable is very expensive cable. So guys, in all of the networks, you do need to learn how to unplug it safely or plug it on. Most of the time, you don't have to do it because this is all done by SAN specialists. SAN specialists are those people who are who are experts on SAN. So most of the time when you buy a SAN, your company buy a SAN, they would come to your location, install this, configure this, and give it to you. And whenever there is an issue, it's not recommended that we go and try to play with it. No. If even somebody asks you, you can clearly tell them, you know what, I'm not a SAN expert. We need to call the vendor. It is very normal. It's very normal. Or otherwise, if they trained you on this, then that's another case. I mean, working with this is not difficult, but still, I won't touch it because I'm not an expert in this. Okay. So here, second thing. So right here, the fourth thing is fiber optic cable. So I'm gonna say fiber optic cable. So this is 4. How many things do we need? you need a SAN device, you do need a HBA here, then you do need a fiber switch and fiber optic cable. So there are 4 things already. And last thing here again, from switch to a storage processor. This piece is known as SP, and SP stands for storage processor. So this is known as storage processor. So from switch to the device, there is another fiber channel cable, and it connects to storage processor. So 4 things you need to remember when working with fiber channel SAN. Working with fiber channel SAN or explaining them. So fine. So this makes its own infrastructure. So now you have a SAN device. You do have a fiber channel cable. You do have a storage processor here. You do have a fiber switch. You do have a fiber channel cable, and then HBA. Guys, the fiber channel switches are made in this manner so that they can have a control over speed. Now, you cannot have control over TCP/IP speed. So whatever is TCP/IP based, it's slower. Whatever is TCP/IP. So SAN is TCP/IP based, it is slower. And here, this is TCP/IP based. This is even iSCSI is TCP/IP based. It is slower than SAN. It cannot reach the same height as FC. Although there are new technologies in iSCSI, they're trying to compete. They're almost there, but still, but since they are almost there, it is as expensive as SAN. It is as expensive as SAN. क्या हुआ? खाना गिर गया?
नहीं नहीं
खुशबू आई है. Okay, here. And guys, we're gonna go for a break in 2 hours. So no, quickly. Here. Okay. Do we understand? SAN, fiber channel SAN is faster than all other storage. What is the reason? The reason is fiber channel SAN uses its own infrastructure to manage the storage. So it uses its own card, it uses its own cable, it uses its own switch, and it uses its own cable and storage processor to connect to the device. So meaning this is not dependent on TCP/IP. What is the speed of TCP/IP? Guys, maximum speed of TCP/IP is at the moment, it is how much? 1 GB. 1 GB. All these network cards that we work with, they're all 1 GB. 1 gigabyte. They're all 1 gigabyte. They're moving towards 10 gigabyte, but it's not very soon. It will reach there, but this needs a complete infrastructure upgrade as well. You need to have switches that are 10 gigabytes as well.
For the 1 gigabyte, you need to have the switches.
Oh yes. But nowadays most of them are. So for now the speed is 1 GB. How long back we were using 100? For longest time we were using 100 MB. Long time, and we used it I think at least for 6 years. And recently it got upgraded to 1 GB. How recently? Maybe 2-3 years back, 4 years back maybe. No more than this. And now we're talking about 10 GB, and it's going more and more. So, but still, but still, it is 1 GB. You will never get 1 GB on this network. Why? Because there are limitations on your network. This network gets heavy. This network, the cable gets clogged with a lot of things. So you cannot get 100% 1 GB. Average. It is said average is this doesn't go more than 400 MB. 300, 400 MB maximum it goes.
There is also
Length and reliability and all that. Guys, this is where fiber channel wins. Fiber channel, to start with, it starts with 3 types of speeds. No, not 100 GB yet. It is 100. Yes, it is 100%. Yes, this is right. So it has 3 speeds: 2 GB, 4 GB, and 8 GB. And it is moving towards 10 GB. Actually, there is already 10 GB, but it is moving towards 100 GB now. It is going towards 100 GB. So fiber channel, so the minimum speed you get is 2 GB. And On average, when you start using, it gives you around 800 megs. So average is 800. Here average is it's maximum 400, but it is between 200 and 400. So here you don't get that much speed. But here, when you get 2 GB of fiber channel, the average it is set. The average is seems when you check the statistics. This gives you 800 MB, and 800 MB is a lot. So here, guys, one more time. The most expensive one is fiber channel storage. The less expensive is iSCSI. Then there is NAS. But then there is a huge difference between a file level storage and a block level storage. So when it comes to block level storage, if your company is smaller, they cannot afford FC. They can still work with iSCSI, which is limited on speed. Is it limited on speed? Otherwise, it's limited on speed. It has a maximum of 1 GB limit, but plus, and then there is other services on the same network as well, right? So on average, you're getting around 300 in good times. But here it has its own infrastructure. This is why fiber channel has it. Fiber channel said, you know what, from the motorway to Rywind, I'm going to make my own road. And who made his own road? Nawaz Sharif made his own road from motorway to Rywind because he doesn't want any interruptions there. Guys, this is exactly what happens in F. So it has its own infrastructure. It has its own infrastructure, own cable, own switch, own hybrid. But now, what do you need to remember? What do you need to remember? You need to remember these components on your fingertips. So whenever the word fiber optic comes, first of all, it is a storage. And when you buy a storage, when you shop around for a storage, guys, when you shop around for a storage, it all matters that how much disk do you need, how much storage do you need. So do you need 10 disk storage, 20 disk storage? And EMC is most expensive company. There are less expensive than EMC as well. There are other companies that are providing fiber channel, similar technology, but they are less expensive. IBM has its own, Dell has its own, but I'm giving you one so that we remember it. I'm giving you one, and I gave you one server which is 3650 so that we can remember it. So here EMC, and your company bought what? EMC VNX 5600, maximum storage capacity 500 disks, and it can use maximum of 24 GB per SP. Now let's talk about, so how many components, what makes the FC infrastructure? What makes the FC? 5 components. 5 components make FC infrastructure. How many components? 5 components. First one, SAN device itself. And second is SP. So let's go from here to up. And then SP, which is a storage processor. And then third one, fiber switch. Then fiber cable. And then HBA, which is host bus adapter. Any one of the component is not working, FC goes down. Any one of the component not working, FC goes down. So now that comes to a next topic, which is how many single point of failures are here? How many single point of failures are here? Guys, this is a single point of failure, SP. If this goes down, cannot connect. Fiber switch is a single point of failure. Your HBA is a single point of failure. For that reason, guys, so this is why there are 2 ports on a HBA. You see, on each HBA there are 2 ports here. So there are 2 ports on each HBA right here. So there are 2 ports. One port connects to one switch, and second port connects to second switch. And from the switch, this switch is connected to one SP, the switch is connected to one SP, and there is a cable. So you see how much redundancy is there. So now let's make single point of failure on this.
There is no storage processor on this picture.
Actually, it's not shown, but it is right here where they are connected. This is storage processor. Other than this picture, you see wherever the real SAN, there is a storage processor everywhere. So let's look at this.
So that's the after the break.
Okay, sure.
At least to digest that.
So guys, here server 1 HBA with 2 ports. One connects to one switch and second port connects to second switch. And then you have a second server, 2 ports, one connects here, second connects to the second switch, and right here they are connected to mass storage master. Actually, this is actually a more high level of SAN, because here you have 2 SAN devices just to have redundancy.
Fiber
But in this case, I still it's
आपने
only one
आपने बिजली चली जाना मैं वो समझ
Yes, 1 HBA per server, but 2 ports.
each HBS.
But 2 ports. Oh, your point is that there is only 1 HBA. If one complete HBA goes down, then what happens? Yes. For that reason, some companies would have 2 HBAs here. So just a quick thing. It's just a quick thing here. Let's look at this. So second, you need to bring a second fiber switch. So let's bring a second fiber switch. And then connect the second port of this HBA to here. And this one connect to a second SP. So this is why, remember, on all VNX devices, there are 2 SPs. All of them, when we saw that diagram, it's right here actually. When we saw the comparison here, all of them has 2 SPs here.
Yeah. Storage.
So storage processor 2. Why? Because there has to be 2 inputs to your storage. Now, what is the main purpose of storage processor? Guys, storage processor is not only a connector. It is not only provides a connection to the infrastructure, but it is also an intelligent CPU as well. It is a CPU as well, storage CPU. It makes decisions on behalf of who is connecting to this storage. So this is why it is not only called just a connector. It is known as storage processor. So it basically decides who needs to connect from here to here and back to and which paths they are coming from. So this is an intelligent processor. It's a storage processor, guys. Now here, so just to fix the SPF, single point of failure, you need to become a second switch, and second port is connected here, and here this switch also is connected here, and this is also connected here as well. So now you have redundant everything. So here, and then on the second server you have the same thing. So second server, and all you need to do is so have one port connected to this switch, and you have second port connected to this port. So you have redundancy on all levels. HBA level, 2 ports, 2 switches, 2 SPs. If any connection goes down, and why is it so? Because you want to have the most efficient, most reliable, and fastest storage. What is reliability? Reliability is that if one path goes down, there should be another path as well. So this gives you 4 paths to actually 4 paths to one server. 4 paths. How many paths? 4. Let's look at this. 2 is here, 2 are here, and then there is a redundant path from switch as well. So this switch is connected to both of them, and this switch is also connected to both of them. If anything goes wrong on this level, this switch can use this SP and connect the server. So there is a redundancy on all levels here. Okay. Before going for a break, guys, I would highly recommend on a blank paper, make this diagram, make all of the components in 4 minutes. In 4 minutes, make this diagram, make all of the components, and remember it. When you make these components, it becomes solid. So I want you to make FC. I want you to make all components before leaving for a break. Show me, and you shouldn't miss out any component, guys. Make one diagram and a very strong diagram. ये हमने इसकी तस्वीर ले ली?
Yes, sir.
Okay, guys, let's
सिंगल
continue.
पॉइंट वेरिएंट के लिए फिर उनको ही एक रिक्वेस्ट करनी पड़ती है क्योंकि ये तो सब
हाँ हाँ, for sure, बिल्कुल बिल्कुल बिल्कुल. क्योंकि your storage specialist, they are specialized to work on SANs. We are not specialized to work on SAN. Now, sometimes if we try to kind of prove ourselves, prove our abilities, you might be able to do it, you might be able to fix it, but there is a huge chance that you'll corrupt it.
yes.
If SAN is corrupted, even support is very expensive. So most of the time, whenever it comes to SAN, always rely on the vendor. So all companies keep a vendor information. So as soon as any problem comes, you would say, you know what, I'm going to call the vendor and we'll ask them what needs to be done in this. SAN is not working. Storage is not accessible. Now, small little issues, yes, we can fix. But if it is really a SAN issue, then it's better to let them work on it.
Concept का पता होना चाहिए
Yes,
बाकी
right. So guys, here, I'm going to come here and I'm going to start with storage, file level storage, block level storage, and in block level we talked about SAN, and in SAN we talked about iSCSI. And fiber channel. In iSCSI or fiber channel, both of them, guys, why are we thinking of SAN? Why do we need SAN? The only reason why we need SAN, we need some reliable storage. We need some, and who is it storage? Who is it who is it required for? Who needs that storage? Who needs the storage? Our ESXi hosts need storage. For that reason, we are shopping around and seeing that what SAN is good for us. Okay, actually, you need extra storage for ESXi. I mean, to start with, if there would have not been a requirement for these, you don't need extra storage. You can rely on local storage. So this is why we were shopping around and we found out that there are two technologies. One is iSCSI, one is fiber channel, and then both are block level storage. They are block level storage, and block level storage, remember in this case. So block level storage are stored in the shape of small blocks. So let's say this is file number 1 stored. And then you have a second file stored in second collection of block. Then you have this. So block level storage has many flexibilities. Everything is stored in shape of blocks, and they are read and read in shape of blocks as well, right?
Some of the, like, you know, when you download a large file from some of the download managers, they show you a like data
Yes.
coming in blocks and then it's resumable.
That is still file level storage, but they are trying to manage it through our application.
But if a connection drops somewhere,
It starts from the same location, but that is application level help. I mean, it is still a file level storage. It is still a file level storage, but what that application is doing, it is just remembering how much is copied and how much needs to be copied. So it is again going in low level, but that cannot increase the speed of read and write. The speed of read and write will remain the same. Even if you're using download managers, even if you're using special manager, that won't increase the speed. Here, technology right from the base, it's different. So it is the technology that makes it faster, not the way it is being done. Okay. So here, block level storage, SAN, iSCSI, FC, and here we knew now that FC is most expensive. FC is most expensive, and in block level storage, guys, where does the block level storage comes from? Guys, block levels. I think this is my own thinking that block level storages are based on exactly how our brain stores information. In our brain, it is also stored as block level. This is where when sometime people would say, "Oh, does that ring a bell?" Now, what does that mean? It means that did you ever heard this word before? Because with one word, you have a complete mind map open. Pakistan, complete mind map open. Canada, complete mind map open. Ferrari, complete mind map open. So in our brain, it is block level as well. So block level is easy to access and everything and all that. Guys, in block level storage, let's remember this one feature. That is known as data deduplication. Data deduplication. Now, data deduplication is a technology in which same blocks are not stored twice. Same block of information, you don't need to store them twice. Same block of information is just stored once, and then a pointer is saved for that type of block. Remember we talked about this, that it's a duplicated data is not saved twice. So so let's say you have two servers, you have two VMs, both are server 2012, and both servers are stored as VM in this storage. Now in this, there are many files that are exactly the same system level files. So what happens is some blocks will be, so on the first time when the server is created, all new blocks are created. But the next time, all similar blocks will be stored as a dot. So this is dot. Now dot is saying that in this place, this block is used. In this place, this block is used. This is data deduplication. So deduplication means no duplicated blocks will be stored. Now duplicated in file level storage, this is not possible. This is not possible. If you have two similar servers, you will be stored 2 times or 3 times or 10 times. So here you're again storing data on that as well. Do we understand deduplication? Deduplication. And opposite of deduplication is duplication. You have duplicated data. Deduplication, no duplicated data. Now, SAN, and then we start with who needs these technologies. Who needs the technology? It is required by our ESXi host. It is required by ESXi host. So here ESXi1, ESXi2, ESXi1, ESXi2, they have their own network cards, TCP/IP network card, and they are living happily ever after. Ta-da! They are living happily ever after. You don't need extra storage. They do have local storages as well. They do have local storages where all. So currently all our VMs are basically stored in this storage. So now comes vMotion. Now comes vMotion. Today we're not starting vMotion. I'm just saying. Now comes vMotion. Guys, vMotion's first requirement. vMotion's first hardcore requirement is that VMs must be outside the ESXi host. VM must be on a shared storage. This is vMotion's first requirement. If this is not met, your machine cannot be vMotioned.
vMotion means transfer.
Yeah, exactly. Transfer of live VM from one host to another.
And if it's in the local storage, you can't do this.
You cannot do this. So the very first requirement is that if you need to have vMotion for this VM, it must be stored outside the storage right here. And not only that, this storage needs to be connected to both of them.
Yeah.
This is what the vMotion's first requirement is. So now from here, now there should be 4 bells ringing in our brain. So this shared storage can be DAS, it can be NAS, it can be iSCSI, or it can be FC. So it can be all of them. So this storage can be all of them. And now let's say, since we are under FC, your company say, you know what, we're going to go with the best of the best. So we're going to spend money. Why? Because this VM is making us per month, let's say this VM is making us per month $10,000 per month. Because it's an online server, and at one point with this server there are let's say 100,000 users connected. 100,000 users connected to this server, and it's making us $10,000 per month. So it makes sense for this one not to compromise your storage. So the cheaper storage you go, you're compromising your storage. Okay. So in this case, they are saying, you know what, we're going to buy best of the best. And then they went into the market and they bought EMC VNX series storage. Yes.
That's a might be a stupid question, but if you have a VM in external storage, like outside there, what's the point to vMotion like this already?
Yes. What is the point of vMotion? So this is what I said. I'm gonna go through vMotion full chapter next week. Not next week, in the next lecture. But for now, I just said I'm just giving you the importance of shared storage. That vMotion, that advanced feature, cannot work without a shared storage. So for now, I just remember that vMotion cannot even work if VM is not sitting outside the storage. Okay. Okay. And then we're going to go into more detail A to Z in vMotion. Okay, here. So since you need to have this company is saying we're going to buy EMC SAN. So they went to the market and they bought this EMC SAN. So first of all, when they went to EMC says, you know what, we're going to send you our own people. So since this product will cost you anywhere from let's say 50,000, within 50,000 you are going to get 3 years contract. 3-year support contract. So they're going to give you support. They're gonna do all of the installation and configuration, and they're going to train your people as well to do just day-to-day administration. So this is what they do. So within 50,000 with device, they are giving you this, and this is, I'm just giving you a rough figure. Maybe it might be more, it might be a little bit less. So they are giving you this. So your company paid them, they came to your organization, and then they brought in what? VNX, EMC, VNX, 5600. 5600. Maximum of how many disks can be there? 500 disks. How much RAM can be there? It can use 24 GB per SP. Now comes those. Now your company also bought, let's say 10 disks, maybe 100 disks, but I'm going to make 10 because I need to explain more. So they bought 10 disks. So 10 disks are now here. Okay, 6 disks. And 6 disks of, so total of the storage that you're getting is 10 terabytes. 10 terabytes. Now, they brought this, they brought the complete infrastructure. So now somebody asked, oh, can I use my Ethernet card with this? What is their answer? No, you do need special card to connect, so they're going to bring everything. They did brought the device. They did brought HBA, so one HBA connects here, the other HBA connects here, and each HBA has 2 ports. So each HBA has 2 ports. And then they also brought 2 switches, one switch and second switch, and these switches are fiber switches, and they are connected through. So this is one, and
HPA is different than the other network card.
yes, it is different. It is totally different. You do need a special network card.
HPA is only for like SAN.
Yes. Only for SAN. Yes, that's correct. So this one is connected here. This one is so one card is connected here, and then comes the second card. The second, so from the second server, it must be connected here, and this one needs to be connected here. And then goes the your SPs. So SP, it comes with, so all of the SAN comes with 2 SP. This is SP0 and this is SP1. And then they are connected in this manner. So this one is connected here, this one is also connected here. And same thing for this other. This one is connected here and this one is also connected. Now you have redundant paths for all of them. So so each complete connection, so let me name them first. So this is our SAN device, number 1. This is our SAN cables, fiber optic cables. This is our SP, storage processors. This is our fiber switch. And this is our HBAs. HBA stands for host bus adapter. And these are again fiber channel cables. Now let's learn a few terminologies here. First of all, this complete infrastructure that SAN builds, this complete network that SAN builds, this is known as fiber. We call it fiber. So, fabric. This is known as fabric. So fabric is the network used by network infrastructure used by FC SAN. Fabric. So this complete network that it is using, so Fabric includes what? It includes the SAN, it includes SP, it includes switch, it includes HPS. So next time when somebody asks you, have you ever worked on, have you ever seen Fabric? Yes, Fabric is defined as the network used by SAN. This is Fabric. Now within Fabric, what we have is, guys, each card and each connector is named something. So just like here, these Ethernet cards are known as Ethernet cards. These are known as, so they are known as Ethernet cards, remember? They are known as Ethernet 0, and then you add more cards, so it is Ethernet 1, 2, and 3. So these normal TCP/IP cards are known as Ethernet cards, right? At the same time, sometimes they are also known as NICs. They're sometimes also known as NICs. And these all cards have a special physical address which is known as a MAC address. Do we know that? So each card is known as MAC address. It has a special number that is known as a MAC address. Guys, this MAC address is unique for all cards. Do we know that?
Yes.
We know that this MAC address will always be unique for this card. This MAC address that is assigned to this card will not be assigned throughout the world to another card. So all the cards basically are not known by IP address. They are known by the MAC address. Guys, exactly like a MAC address, all HBAs have a special number on each port, and that is known as WAN. WAN. Sorry, WWN. WWN. Worldwide names. Worldwide names. Worldwide name is assigned to each device in a fiber network. In a fiber channel network, WWN. So if I look at here, I'm going to say SAN, WWN, and HBA. Let's see what comes up. A dinosaur comes up. Okay, guys, here. So this is what WWN is. Let's look at this here. I think it's very small. Guys, WWN. So there are two. So there's a HBA1, HBA2, and basically this number here, this is a WWN. It is almost similar to MAC address. It is almost similar to MAC address. But on HBA, it is known as, so this is pointing actually right here, right this one. So this is VM HBA1, this is HBA2. So this one is a WWN of this number, this long number, and WWN stands for worldwide name. So just like a MAC address is a physical address on normal TCP/IP devices, and on all HBA fiber switch devices, fiber devices, they are known as WWN. The only thing to remember, because most of the time you won't be troubleshooting this, but you must know what is a unique name given to each device, each number given to each fiber channel device. So that is known as WWN. And WWN, I'm going to write here, WWN stands for worldwide name. Worldwide name. And worldwide name is assigned to each HBA. So each HBA, if it has 2 ports, it has 2 WWN. Worldwide name.
It's assigned to each port?
It is assigned to each port, yes. So let's look at this. Yeah, this one is more clear. So as you can see here, WWN of A, card A is this long number, this is WWN. Then WWN B card number is this, then here. So this server is A, it has 2 ports, and their WWN is this. And this server is B, it has port 3 and 4, it has these WWN. Now on this side, on the other side, as you can see, so basically look at this here. This is SAN device. It is connected to Fabric 1, and Fabric 1 means it is connected to switch here. So it is going from here to on this side, on this server. I think this is a server or maybe a device that where it connects to. And on this side, it is connected to SAN 1, SAN 2. This is more complicated SAN structure. We don't need to remember that how most complicated, because we won't be managing SAN. This is mostly, and SAN is a technology in itself. Guys, never ever claim that you do know SAN. Just tell them straightforward, you know what, I know the basics of SAN. I know basics how the structure is, but you cannot claim because it's a complete technology. You need to learn it in order to do it. So, but this is how much we need to remember and understand. So there is a SAN device. It has disks inside, and disks are connected to SP. SPs are intelligent processors that not only connects to the HBAs, but also they decide. They also decide. Now look at it. These SPs also decide that from this host to this SP, which paths to go for. Now let's look at it. Just to get to this host, how many paths do we have? How many? So one path is port number 1 connects to switch number 1. So I'm going to write here port 1, switch 1, SP0, and then you connect to SAN device. So this is one path. And same one, port 2, switch 1, SP0. And then port 1, switch 1, SP1. And then port 2, switch 2. This is switch 0, switch 0, switch 1, switch 1, SP1. So just to get to one host, you have 4 paths. If anyone fails, if this fails, it can use this path. If this fails, it can use this path. Do we understand this numbering?
That's only if you have the HBA. You have
No. There is only one HBA. There is one HBA with 2 ports.
providing port.
Huh? Then 2 HBA will provide you 4 paths. And not only 4, 8 paths. Now one more time. Should I make this again? One more time. Let's look at this. So path number 1 is, this is port 0 and this is port 1. And this is switch 0 and this is switch 1 and this is SP0, SP1. Simple. So I'm going to start with port 0. Port 0 connects to switch 0 and it connects to SP0. So this is path number 1. And then port 0 connects to switch 0, actually switch 1. It connects to port 0 connects to switch 1 and SP0. This is one path.
So that's SP1.
No, so both ports are going here, but both are connecting here. That's another one.
Okay,
So
that's fine.
now the second path from second port. So actually from the first one actually. So this is just these ports are going through. So all paths are going to SP1. So now port number 1, switch number 0 connect to SP1. And then port number 1 connects to S1, switch number 1 and SP1. So 4 paths to one server.
4 part to switches and from switches to SP4.
Exactly.
And then it's still
Exactly. Now, each is known as a path. This is path 0. This is known as path 1. This is known as path 2. This is known as path 3. Guys, why am I giving you this path information? Because SP intelligently manages these paths. If one path is not available, SP is intelligent enough to connect to the storage to another path. If the second path is not working, then it connects to a third path.
It's like in subnet.
It is just like subnetting, but this is redundant paths to one host. This is called reliability. This is a very high reliability. Now second thing here is, so this is reliability. Now second thing, let's look at this here. Path. Guys, SANs have another option. So SAN, we are discussing what? We just knew that SAN, the network of SAN is known as fabric. And then each device in SAN, they are assigned a special number that is known as worldwide name, and worldwide name is assigned to all of them. Worldwide name is a hexadecimal number. As you can see right here, it is a hexadecimal number. It's a hexadecimal number. And just like in MAC addresses, in WWN, half number is assigned to the vendor and half is assigned to the device. So and now what do I mean by this? Let's look at this here. Now these 4 numbers, 1, 2, 3, 4, they belong to 4 different devices. Okay? But what is similar in all of them? The first half is exactly the same. So all start with C003 and FF, C03, FF, and 4C. Just the last digits are different. So half of the number is assigned to vendor. For example, if they all belong to EMC company, then their vendor ID will always be the same. If they all belong to IBM, then their vendor ID will always be the same. So half, and same goes for MAC addresses as well. First half it belongs to vendor and last half belongs to the device. So from first half, so WWNs are made up of two parts. It's a hexadecimal address, and it has two halves. First part belongs to a vendor, and the second part belongs to a device. Okay. Guys, these all slides. You can get the slides if you can give me the USB, because I won't be able to send it to them. They are big. They can't be emailed. So if you need them, just give me the USB and I'll give you all of the slides. So we are here in storage. We are going through storage. We talked about local storage, fiber storage, virtual machine, SAN. We are going through this here, fiber channel, SAN, and it's right here. So this is the fabric diagram that we discussed. That's right here. This is your storage. So right here you have a storage. I just made it here. The storage is actually the up here. So this is a storage, and then this is SPs. These are fiber switches, and then here you have HBAs. Here you have HBAs. So, and then next here, this is talking about right here, WWN right here. This is a WWN. It's a unique 64-bit address, and then assigned to a fabric. So just like this, and then half of the address is for the vendor, and half is for the device. So here I'm gonna write that this is a 64-bit address, 64-bit address, and I'm gonna say here write one address. Let's say 0000F08C 0895DE. Half of it belongs to a vendor, and half of it belongs to a device. So just remember this. Now guys, it comes the next thing here. So fabric, what is fabric? The network used by SAN is fabric. WWN, it's the unique name assigned to each SAN device. Unique name assigned to each SAN device. Next one, WWN is 64-bit address, and half of it for the vendor and half is for the device. It is for all SAN devices, not only HBAs. As you can see right here, switch has its own. Switch has its own WWN. Your devices have its own WWN. So just like all the devices in TCP/IP, they have numbers. So whatever device that connects in, it has its own SP. It has its own WWN. Now next thing here we need to talk about before I start working on a disk. Next thing here is SAN security. SAN security, we need to remember two concepts here. So here, SAN security. Now, before even going to SAN security, because there is one concept that will be used. So guys, here, let's look at this. SAN device, SAN device is a device that has multiple disks attached to them, right? It has multiple disks. Guys, these disks are raw disks. They are raw disks. In order to use them, we need to actually make logical partitions of the disk. So if you need to use this disk, you need to make a logical partition. And that logical partition is known as LUN, or logical unit number. So this disk is known as LUN, which stands for logical unit number. So which is right here. So this is LUN 0 to 10, and this is logical partition. So just like in physical computers, we have a disk, you create a logical partition, you can create C drive, D drive. Those are logical partitions, right? From one disk. So same thing, these disks need to be divided into logical partition and then provided to the client. So directly raw disk cannot be given to a client. Now this LUN, or logical unit number, this is what it is. It is a logical partition of the raw disk that needs to be provided to ESXi host. Now these LUNs can be of many different sizes. They can be of one complete disk. So if you have 1 TB disk, you can create a LUN of 1 TB disk. Or what you can do, you can combine these disks and make a bigger logical partition. For example, this LUN is, let's say, 1 TB in size. But for this ESXi host, you have a requirement of 4 TB. You need to give a 4 TB disk. So in that case, what you can do, you can combine these disks together and make one logical partition of 4 TB. So this will be LUN 1. So this is LUN 2, LUN 0. So basically, these logical unit numbers are logical partitions that are made from the disk and given provided to ESXi host.
Similar to how Windows 2000.
Exactly.
2001.
It is exactly the same concept. In Windows, you do create a disk. You do get a disk, and then you logically partition it. When you logically partition it, then you can connect it. Yes. Okay. So right here, so guys, you do get a SAN. Now actually we are on the operational part of SAN. So now you do, so these people came to your organization, they installed SAN, they installed switches, they installed HPA, they connected everything, and now they are saying that how much disk do you need on this? Now remember where we started from? We started from vMotion, because vMotion has the requirement of having this disk. So this shared disk is basically this LUN that is connected. This is a shared disk. So that shared disk is basically created inside a SAN, and then it is connected to, given as a disk to both of them. And then once this disk is created, it will have its own WWN. So each LUN has its own WWN. So this disk will be recognized by its own WWN. Okay, just one more time. I mean, this is a second part of SAN that we need to understand. First part of SAN was just to understand the infrastructure. Infrastructure, is it understandable? You need to have SAN, you need to have a switch, you need to have cables, you need to have SPs, you need to have HBAs. Once they are connected, then you see how many redundant paths there are. Now, SAN has the ability to use something called concept of multipathing. SAN uses a multipathing feature, and multipathing feature is used. So this is a multipathing feature. It is a multipathing feature. So there can be something called. It is a multipathing feature. It's right here. So when transferring, so multipathing feature is this, multipathing. Multipathing is when transferring data between host and storage. So when transferring data between host and storage, What it does, the SAN uses a technique known as multipathing. What is multipathing? Multipathing allows you to have more than one physical path from host to LUNs to the storage. And these are multiple paths. Remember these multiple paths? Because you have two roads going to here, then two goes from here. So this is how you have multipathing. And SP decides that which multipathing is there. So now we remember, so we started with fabric, WWN. So what is the first one? Fabric. Second one, WWN. And then we have, and then we talked about 64-bit address. Half part is vendor, half part is this. And then now we are talking about LUNs. So here, LUN, which is number 3 in your new concept. Number 3. What is LUN? LUN stands for logical unit number. Logical unit number are created based on real disks here. So you have real disks, then based on these disks we create a logical unit number, and basically these LUNs are provided to the ESXi host so that they can use them. Okay. Now this comes to our second thing, which is SAN security. How SAN provides security? Now, in order to SAN provide security, okay, just on the topic of multipathing. Multipathing, what is the main advantage of multipathing? Which is this. Number one, it path fails over. A single path from the host LUN consists of, so a single path. A single path consists of what? It consists of HBA. It consists of a switch port. It is consisting of a switch cable and the SP. Remember the single point of failure? These are all of the single point of failure. If any component of the path fails, the host select another available path IO. The process of detecting failed path and switching to another one is called path failover. So it automatically fails over to another path. This is actually a feature of multipathing. This is why it is most reliable, because now if one path fails, it automatically knows to connect to another path. It is same thing what we discussed before in network cards.
Yeah.
Network card. You have redundant path, they can fail over and they give you double speed. Right? Now here we need to discuss two security options here, and two security options in here are known as these. Zoning. So one is called zoning, and second is called LUN masking. So two options used to protect your SAN storage. Two options used to protect your SAN storage. So here, these two options, so I'm going to say these two options are used to protect SAN storage. Now, how are they used? Guys, zoning is done on switch level. Zoning, so I'm going to say zoning is done on switch level, whereas LUN masking is done on SP level. Second one, LUN masking is done on SP level. So LUN masking is done on SP level. Zoning is done on switch level. What is the main purpose? Main purpose is just to protect the paths if one path is not available to another. So first of all, zoning. So zoning is done on switch level, meaning, so I'll let you write and then so zoning is done on switch level. So I have exactly 10 more minutes for theory, and then we'll install the storage. You booked the exam? Are they opening? The software is working? Everything is fine? So just do 411. Guys, how much time do you need for 411? 2 days is enough?
Six chapters.
No, 411 exam.
Oh. Yeah.
3 days?
1 to 4 days.
Huh?
3 to 4 days.
No?
For 100%, 3 to 4
No,
days.
he already did Citrix and SCCM before. So I think 2 days is enough. Just buy a voucher. Are there any discounted vouchers there?
No.
Just a
No?
little bit, but yeah, on vouchers.
Hmm?
There is a $90.
$90 voucher for how many days?
So some are $85.
Okay. Where on eBay
for
or
1
IT
week.
voucher?
IT promotions.
Voucher for exam.
Okay,
Some are
voucher for exam.
some for 85 something, and
Okay.
they has only 1 week.
So it's called voucher for exam.
Yeah, voucher
This is
for
the website. Look at the website for exam.
for you will write the number 4.
Okay.
It has like $89.
You missed the sale.
Yeah, that sale was excellent and people went through.
Yeah. What is the website address?
Exam for voucher. Number 4.
Voucher for exam.
Voucher for exam. Okay. Voucher for exam. Voucher for exam. FOR.
No, sir. Number 4.
For number 4. So guys, here, book it for 3 days, 2 days from now, and just go for it, please. Okay, here. Fabric. What is the word? Fabric. Second one, WWN, 64-bit, and logical unit number. Logical unit number. What is a logical unit number? It is just a logical disk that is taken from the raw disk. Okay, so this is done. Guys, security, zoning, and non-masking. So now remember this. Now remember, what you are trying to do is you are basically trying to protect people from unnecessarily connect to SAN. Unnecessarily. So if all the people, all hosts, because what happens is, guys, as soon as SAN is on, and as soon as logical unit disks are created, so there will be 100 disks, let's say, 100 LUNs are created. Guys, they will be seen from all servers. They will be seen from all servers. Now, if these logical unit number are seen by not only these two, but all 400 servers, then people might unnecessarily connect to them, and people might unnecessarily, if they are open. So what we do, we put some roadblocks. So I would use the word roadblock. Now, roadblock can be done right on switch level. So right on the switch level, I'm going to say, you know what, this path is not available for everyone. I'm going to say this path from this switch to this SP is only available for E1, ESXi1. So this is known as zoning. In zoning, what you do, you put in restriction on switch level. So this is one type of, so this is known as zoning is done on switch level. And if you look at this here, so zoning is done right here. Zoning is done on switch level. So you do zoning here, you're going to say that path number 1, 2, 0, 1, 2, 3 is not available for everyone, but this is only available for ESXi1. Whereas fourth path is available for ESXi2. I'm just giving you a simple example. Whereas non-masking is done on SP level. So So Lund masking is just this. Again, it's the same concept that how many logical disks are available on to which servers. So which disk is available to which server. So basically, what it does, if you look at the definition here, it says that Lund masking is done on SP or server level, makes the logical unit number invisible to targeted servers. So it makes it, since it is not available, nobody can connect to it. So it is just a matter of that how many disks are available for how many servers. So two types of security. One, hide your logical unit number. So it's not available to anyone. And second one, hide the paths. So one is hiding the complete path. The other one is hiding the disk. It's just that simple. So Lund masking, they are technical words actually, but all you need to remember that masking is done on logical disk level, whereas zoning is done on switch level. That which path is available for who. Okay. Okay, in multipathing, that's another thing here. That in multipathing, there are three concepts used, which is most recently used path, fixed path, or round robin. Now, let's say you have 4 paths available to this ESXi host. Now, how many types of techniques host can connect to a storage? How many types of techniques? The technique says fixed path. So fixed path, if you go with fixed path technique, that is saying that whenever this host needs to connect to a storage, it will always use the most recent path. So sorry, before that, most recent path. So most recently, path 0 was used, so always this path will be used. And second last time, maybe this path was used, so use the same path. So most recently, whatever is used, it is using it. Now, secondly, fixed path. Fixed path is simply that always, whenever this host needs to connect here, it should always use this path and no other path will be used. So that's the second technique. And the third is round robin. And we all know what round robin is. Round robin is, what is round robin? So use this path first, second time this, then this, then start here again. So this is round robin. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2. So it's using all the paths at the same time. Yes.
So if we use the fixed path, then there would be no single point failure.
Then there would be no single point of failure. Yes. Then there are some consequences, but then fixed path meaning that maybe you're not using the same path for any other host. You're not using the same path for any other host, and this path is only for Nawaz Sharif. I mean, just to understand. This path is fixed for this host and no one else is using. But if you go with round robin, it is used by other technologies as well. It is used by other server, other logical unit number, and everyone. So there are give and take. So here VM kernel resumes using the fixed path when the connectivity is restored. So actually mostly this is for when one path is not available. So let's say when one path is dead, then how should it start next time? So most recent path, fixed path, or round robin. Okay. Guys, with this, let's start configuring our storage, and we'll continue next storage concepts in the next class. So here, but just a quick look at iSCSI. Before that, just a quick look at iSCSI. This is iSCSI. Guys, iSCSI is this. So here you do have E1 and E2, and then you do have a shared storage. And shared storage is connected here. Same for iSCSI. In iSCSI, so I'm gonna make iSCSI right here. Guys, this area is very important to understand about SAN interviews. So this is very, very important. Remember it, have it on your fingertips. I would say create mind maps for this. So here I'm gonna create iSCSI. So two servers. And then both of them need a shared storage for who? Why do they need shared storage? Why do they need shared storage? vMotion is that feature because of that you're trying to bring a shared storage. So what is vMotion? vMotion is the movement of live machine from one place to another, and one hardcore requirement for vMotion is that they should be sitting in a shared storage. They should be sitting on a shared storage. Okay? So they should be sitting on a shared storage. Now, if they are sitting on a shared storage, you need to get a SAN type of. So if you buy this SAN, fiber channel SAN, then you need to remember all this. But if you buy iSCSI SAN, same, you need to get a iSCSI device, iSCSI SAN. So here I'm gonna create iSCSI SAN. So this is I'm gonna bring. Now iSCSI SAN comes in two different forms. Guys, fiber channel SAN just comes as hardware. You cannot have a virtual SAN. As far as I know, maybe now there might be. But if you have a virtual SAN, then basically that kind of goes against these infrastructure options. Because fiber channel SAN is famous because it has its own infrastructure and gives you full speed. Whereas iSCSI comes in two forms. It comes as a hardware as well, and it comes as a virtual storage as well. And in this lab, we're going to use a virtual storage. So you need to bring a device, either buy a device or get a virtual storage. If you buy a device, it is exactly like you go to Canada Computer, ask them, I need a iSCSI SAN. They would give you many different devices and basically what they are giving you is exactly the same device. It has a raw disks inside. It has a raw disk inside and it's the iSCSI device. But if you need to test it in a lab, then we use some software. So the software we're going to use is called OpenFiler. OpenFiler is a free iSCSI SAN device software. So by using OpenFiler, we can completely simulate iSCSI SAN. So we are going to use OpenFiler SAN. Other than this, there is also something called FreeNAS. Other than this, you can also create a iSCSI SAN using Server 2012. In Server 2012, there is also a feature of iSCSI Target and iSCSI Initiator. You can also use that as well. That also gives you a iSCSI SAN. So here, and also you can use Server 2012. So guys, in order to make iSCSI, you need to have these. You need to have an iSCSI device. And then all you need to do, instead of using fiber switch, HBA, fiber cable, all you need to do, just connect this SAN to your local TCP IP network. So we connected you to our local TCP IP network. And as soon as it is connected, then guys, on SAN side, what type of device do you need here? HBA. This was HBA, right? HBA stands for? HBA stands for host bus adapter. Host bus adapter. Guys, if you have iSCSI SAN, then you need a software iSCSI initiator. Remember in 2012 we learned this, that if you need to use iSCSI, on this side you need iSCSI initiator. And on server side, you need iSCSI target.
On server side.
So server side is iSCSI target. So here, where it connect to, this is iSCSI target.
So it is on SAN.
Yes, on SAN.
iSCSI SAN.
Yes, iSCSI SAN. Yes. So iSCSI SAN, server side is iSCSI target, whereas in SAN FC it was SP. It was SP. So what is your question?
So actually, you are saying on server side, because on server side it is.
Oh, sorry about that. I'm really sorry. Yes, on SAN, on iSCSI device side. On iSCSI device side, you need to have iSCSI target. So target is always on the device side. And on the client side, you need to have iSCSI initiator. So iSCSI initiator is actually a HBA for iSCSI. So this is a HBA for iSCSI. Ta-da! We're all batteries going down. It is draining. It is draining heavily. Just 2 more minutes. Just 2 more minutes on this. Just 2 more minutes on this, guys. Right here. So on this, so I'm not going to go into huge big detail, but so here all you need on server side, you need iSCSI initiator, and iSCSI initiator is of two types. That is software initiator and hardware initiator. The only difference is if you buy a hardware initiator, it comes as a card, and it gives you a little bit more speed. If you get a software initiator, it's slower than hardware. That's the only difference. In both cases, it is an initiator. So initiator is on the client side, and initiator is of two types, software and hardware. In hardware, you would need to go and buy a physical card and install it. And this gives you more throughput, more better speed. Whereas on this side, and rest, everything is same, except here we have WWN. WWN stands for worldwide name. Have you heard of WWF? Never heard of WWF? World Wrestling Federation. Yeah. Here, WWN, guys, here they are known as IQNs. They are known as IQN. IQN stands for iSCSI unique number. Same thing as WWN. So this is known as iSCSI unique number. iSCSI unique number. And you can remember the same concept of WWN. Your SAN, fiber channel SAN, uses WWN, whereas iSCSI uses IQNs. And IQN is that unique number that is assigned to each iSCSI device. So IQN stands for iSCSI unique number, whereas WWN, worldwide name, unique. They are also unique numbers for SAN devices. Okay, so here you have iSCSI. Now REST is the same. REST is you get a raw disk and then you create logical unit number inside. So combine two disks and create a logical unit number. So you created lone 0 and then connect it, give it to these two hosts so that they can use it. So REST is the same. So there are very few things to remember. Very few things. Yes. IQN is iSCSI unique number. iSCSI unique number. So I stands for iSCSI, Q stands for unique, and number. N stands for number.
So what we do that when we create iSCSI storage, IQN, right?
In the video?
Yeah.
Oh yes. It is all IQN. So now guys, based on this, so let's see a big difference between the two. The big difference is here fiber channel has its own infrastructure. That's why they give you a bigger speed, more reliability, and a lot of other features. And this is also a block level storage, but it cannot compete with fiber channel because they are relying on their own infrastructure, whereas iSCSI is relying on your TCP/IP network. So it is just TCP/IP network speed. It cannot go beyond TCP/IP because this is all based on TCP/IP. Okay.
It is giving iSCSI qualified name.
Qualified name. Sorry guys, I'm really sorry. Sorry. Just this one. So it is qualified name. Sorry about that. I was thinking unique doesn't start with Q. So qualified name. Thank you. Yes. It was not Hazamable. It was yes. So it is IQN. No. Sometimes we need to check.
Yeah.
So here. Okay, so now let me give you a few tips about the lab, and then you can do the lab on your own, and it is lab number 9. It is video number 9. Video number 9 is all about storage, setting up storage. So this is what we need to do on overall. So overall, guys, just think of this as this. We have 2 ESXi hosts. How many ESXi hosts? 1 and 2. So there are two ESXi hosts. For now, our VM is sitting inside local storage. For now, it is here. But our goal is to have a shared storage, and connect these both hosts here, and then move this VM storage inside here. So it shouldn't be sitting here. So this is our goal. In order to do this, guys, what we do, we bring a software called OpenFiler, and I gave you OpenFiler, I think, the first day when I gave you the software. It is in the folder. It is in the folder. If you just check, because you need to complete the lab. So what happens is, first of all, we install OpenFiler, and video will guide you guys. We install OpenFiler. It is just installed like any other server. So OpenFiler is installed. Once it is installed, then you need to set up IP addresses on this, and then access OpenFiler from vCenter. So this is your network. So first you install OpenFiler. Number one. It's not, huh? Yes, it can be downloaded. It can be downloaded. It's just the same software. It is just the same software, guys. So you can easily go to just say download OpenFiler. And once you download OpenFiler, it's really easy. But what is difficult? Just to configure OpenFiler. Configuring OpenFiler involves 5 or 6 extra steps. So in this, you would attach a disk and then make disk a logical partition. So you need a disk, then you would make it a partition, and then you would convert it into a logical unit number. So 3 steps, 1, 2, 3. And these 3, you need to do something extra as well. Now, I would highly recommend that when you do this, pause video and move. Pause, move, pause, move. Do not try to listen to the complete video and then do it, because it might be you might miss out some steps.
There are so many steps.
There are so many steps. There are so many steps. So this video number 9, you need to first do this, and then, guys, I'm just giving you high-level steps. High-level step is, once this logical unit number is created, then you need to connect it here. But before connecting, I'll show you what. So before connecting, all you need to do, first of all, add iSCSI initiators here. So you need to add iSCSI initiators here as well. And this is done just once on your ESXi host. So iSCSI initiator will be connected here. Then through this initiator, you will be connected to this storage. And this disk is basically nothing but this logical unit number here.
So we also need to make the volume group, right?
In this, yes, you need to create a disk, then partition, then volume group, then LAN mapping, and all that. Yes, there are few steps, guys, but do not be panicked, because you don't have to be specialist on OpenFiler, because OpenFiler will be configured by storage team. But here we want to work with storage. That's why we're making it. So I would highly recommend, before doing video 9, take a snapshot of your complete environment and then start doing it, because maybe it might not work. Then you can revert back instead of troubleshoot a lot. Just revert back, start again. And I would highly recommend. Okay, so you have all of the steps. Okay, yes, that would be good as well. If you have steps, yes. So I'm going to this video now. Not video. I'll just quickly show you how to just quickly do the install. You're sharing the steps as well? Okay. So here, all you need to do, I need to create a new VM. So I'll leave my environment as is, and then I'll create a new VM. And once you create a new VM, it will ask you which operating system do you need. So here I'm going to say, guys, you won't be able to, maybe you might not be able to follow me. Just look at the screen so that you can just get an overall picture, and then you can follow the video. Okay. Then you can follow the video. Okay, so here, all I need to do in order to configure this, I'll create a new VM and then move here next. And from here, install image, I'll give you the ISO, it's fine. So here, just go here, browse. And in browse, I'm going to go back to my VM5. In my folder, I have it actually in my ISOs. I go down. This is OpenFiler. So I'm using 2.99. You might be using something else. It's fine. Huh? 2.99, it's fine. And it's not a huge big software, it's just 500 megs. So you connect, you start your VM with this ISO and next. And here make sure it is connected to, it is Linux, and then here you just select, you can select Ubuntu as well, or I can go with other Linux 64-bit, any other Linux 64. Now newer version can automatically detect Linux, newer version. I have older version, it's not detecting. If it is not, just select Linux and just say select others Linux, and here name it accordingly. So we're gonna name it Canucks OPF, I think 01, open filer 01, huh? OF01, okay. And here I'm gonna just make sure that this is not 8 GB. This is should be at least 20 GB. So this is 20 GB, and next, and done. And as soon as you do, it will start installing this server called OpenFiler. Do you have USB? I'll just give it to you. So I'm just putting it on your root. So it starts like this. As soon as it goes here, it goes to OpenFiler. You just need to press enter. Most of the installation it will automatically do. And so it comes here. You don't have to do much here, just select next. So it is installing OpenFiler. Just say yes, just go next. So most of the time you need to say yes, next, yes, next. And here is the most important part where you need to set up IP address. I said just 2 minutes and I'm spending 2 hours. Okay. I know it won't. So what I want you to do, guys. So yes. So I'm gonna go here. Okay. इनकी USB गुम हो गई है यार एक सेकंड मुझे एक अजीबोगरीब USB मिली थी
सर हम तो सबके बैग चेक करने लगे थे
आज गुम हुई है कि कब की बात
सर अभी
है
थोड़ी देर पहले
अभी नहीं मैं तो 2 हफ्ते पहले की बात कर रहा हूँ
नहीं
एक बहुत ही चूई टाइप USB थी
ये सोनी ब्लैक
अच्छा यार जरा किसी ने अगर ले लिया तो बताना नहीं है बिल्कुल भी मुझे देनी है मैंने वापस नहीं करनी okay guys here look at this here all you need to do you need to go to playlist you need to go to here.
Hello everyone.
And if you finished video which one?
VMware vSphere 5.5.
This is video 9. So you need to finish 9. Please finish 9. Please. Because and you need to finish this VDS. You finish VDS as well. You need to finish VDS as well. And then 10,
Okay.
we're gonna do
Now,
V motion from
now,
next. Dun, dun.
now what I have is
Okay,
VMware
guys, here this
VM.
video, this open
Hello
filer
everyone,
video.
and welcome to another video. It is part 9
Yeah,
of this
it's a
video
quick, but
series
the
about VCF
understanding is the main
5.5, VMware
understanding that
VCF
you need to do.
5.5.
Yes, if you follow the video,
In
it's
this
fine, but I want you
video,
to understand the complete concept. So here,
open
and if you can, whoever is going forward,
01
moving with videos, just do
my
all of
domain
them.
name.
Just do all of the videos. So
It is
guys,
not
right here, I'm
necessary,
at this
but
step, and I think this is slow
if
enough
later
to
on
understand. But
you want
still,
to
I would say just have some speed breakers here and then connect and do. Excellent, guys. Very good. Huh? Oh yes, open filer. आपके पास
go
आपकी
into
USB अभी
block
इसमें
devices,
डाल दो।
within block devices, select the disk that we need to create LUN of. So
अच्छा,
we have
तो
decided not
बाकी ये
to
करना है
work with
गाइस
the
कि हमने
system.
सीरियसली अपने
Here
रेज्यूमे
it
बनाने
has
हैं।
system partition.
तो
If you
पहला
view,
जो है
it
पहला
already
उन्होंने
has 3 partitions. These are the system
शम्स
partitions
ने शुरू किया है,
for
शम्स को जॉब मिल गई है
OpenFire or Linux.
और इसी तरह वेस्ट टेस्ट का बाकियों
I'm
को भी
gonna
मिल
use
जाएगी।
this. There are
तो करना
0
यह है कि
partition
हमने
of
भी
this.
अपने
So
रेज्यूमे जो है बहुत बड़ी अच्छी तरह बनाने हैं और इंशाल्लाह
this
होप्स हाई रखनी है और
and
इंशाल्लाह
create
हमारा काम
partition.
जल्दी हो जाए।
Now when we create partition, it says it is not being
Thank you
used
guys
at the
and see
moment.
you
So I
next
just
week.
clicked over there one more time. I'll go to block devices.
Thursday. No next week. जनवरी के बाद नहीं हुई है कुछ छुट्टी, ये कैसी बात हो गई है? और फैमिली डे पे भी छुट्टी नहीं, मैंने छुट्टी की सर फैमिली डे पे।